All right, so this is an MCAT lever question. Now, whenever we're dealing with lever questions, it's a lot easier than it looks. Essentially, what we want to do is we want to do the force times the distance from which it's applied is equal to the force times the distance, right? So what we're dealing with is we're dealing with a lever, and we're applying, let's say there's a fulcrum here. It doesn't really matter if it's like a lever that has a fulcrum on the bottom or if it's hanging, but I usually draw this just because it's easier. And then, of course, the force times the distance from the fulcrum. And so, again, whenever I see a lever, I immediately draw this out. And that way, that's going to kind of allow me to fill in these numbers, right? Because usually, like, the wording on this question is kind of long and it's kind of complicated. So it says the lever has a length of 1.5 meters from the fulcrum to the point where the force is applied. So 1.5 meters this way. So the first distance is 1.5 meters. So we'll say here, and we're applying a force here 1.5 meters away, right? And the heavy object is placed at a distance of 0.5 meters away from the fulcrum. So 0.5, so the distance on this one is 0.5. And you can write out units. I would generally recommend it just because it kind of makes it more clear what we're dealing with. So 0.5, and the object is, we don't know the weight of the object, so we don't know the force that the object is exerting here. So this is the force. So this is a question mark, right? That we know the force we're exerting over here. So we are applying 200 newtons here, 200 newtons over here, so 200. So force times distance, 200 times 1.5. And of course, that gets us the torque, but we don't really have to deal with torque here because we're just setting these equal to each other. But really, this is torque on one side is equal to torque on the other, right? So 200 times 1.5. What is 200 times 1.5? Well, that's the same thing as like the number times half of it. So 200 times 1.5 is 200 plus 100, and that's 300, right? So this side is 300, and that's equal to 0.5 times F, right? So F times 0.5, right? And of course, the correct answer here is going to be in force. They're going to be this. So what we do is 300 divided by 0.5. That's the same thing as multiplying by 2. And that's equal to 600. So force is equal to, 600 newtons. So I kind of did this equation backwards. I kind of went up rather than down. Usually you go down. But it kind of works for me because I'm kind of solving the equation that I drew out here relating to the lever. And again, hopefully you're more organized than I am. But whatever really method of organization works for you, if you want the kind of controlled chaos that I do, then you're welcome to do that, of course. And so the correct answer, of course, is going to be 600 newtons, right? And so 600 newtons are applied on this side, right? And that's the object. But again, I encourage you not to think in terms of like objects and whatever. I encourage you just to think in terms of forces being applied. So one force is applied on one side, one force is applied on the other. Each one has a distance, very straightforward. Right, and I think typically with lever questions on the MCAT, they're going to be like this. They're going to be very straightforward. They're not going to be too difficult. And so this is how you want to think of it. All right, so correct answer here is going to be D.